everyone. Welcome and apologies for the slight delay. My name is Dragoș Ciobanu and I am super excited. Thank you very much. We will be well hydrated. Thank you. Very excited to chair this session on translation technologies. Because we're already behind, I'm not going to take any of your time, and I will just say that we have 4 very exciting presentations coming up. We will do our very best to keep to time, so if we run out of time for questions, I trust that you will speak to the presenters afterwards. I will probably just remind everyone that we have a roundtable discussion afterwards, so let's try and be very organized. The presenters are already here, and we will start with Mr. Daniel Kluwanek, who will be speaking to us about neuro-machine translation in the DGD, the European Commission. So without further ado, many thanks, and over to you.
Hello, good afternoon here in Nitre. It's actually my birthplace, but we agreed that it would be better to talk in English. I say in advance that some terms maybe don't have equivalents yet in Slovakian, so with some patience I would like to support also and thank our interpreters behind. Thank you for being here, and I jump right to the stuff. And would like to share with you our experience as the Director General for Translation with using technologies, namely machine translation, and from the point of view of users, but also as creators. And this sounds already too technical, right? I will try to put it anyway in useful words. I will talk about just paradigms, mainly about inspiration taken from biology, and to put some concepts into understanding so that it might work as a motivation for avoiding a feeling of that scarecrow we were hearing this morning. It is really not like that. And for our translators, most of them say it's good to try to understand how the machine works, because then it is easier for us to work with it, and in particular to forgive the machine all that stupidity. And still, it's a good tool which helps in many situations. And I will not talk about mathematics and too technical details, programming, nothing like that, and even philosophical questions and things about consciousness, free will, etc. I will leave for real social scientists. So let's start with good news. Actually, this is neither good nor news. It's from 2013. It's a study from Oxford University putting probabilities of jobs being replaced by machines. And this was a very influential study, generating a lot of quotations, etc., ranking 700 jobs of this probability. Some excerpt you can see. And having seen also the profession of translators with some probability being replaced in a foreseeable future, 38%, followed with even higher probability, 48% being replaced, computers, programmers. It brought also some dynamic into discussions. But actually, the good news are really coming since then. Several organizations made more details inside in these prognosis on markets, labor markets. And one of the latest was published right now in September 2018 by World Economic Forum. And all are quite equal in interpreting these numbers. These are actually tasks in jobs which are replaceable by machines, but all professions consist of many tasks, so this will result in reshuffling processes in industries and reorganization of working methods, And actually, the conclusion was that more jobs will be created than will be dismissed by the new technologies. Even more than 75% surplus is expected. But, and the big but is, the reskilling will be necessary. The EU also screams that digital skills for digital age are necessary. This would be also my first very spontaneous response to the questions which we concluded the morning session. What to teach, basically, if it is a transferable skill, the adaptation, simply to be open-minded to adapt to things which are coming. At the DGT we started to produce our own system since some time ago. We used machine translation since the 70s, but our own system, the decision came rather lately. Some of us might be familiar that we used statistical machine translation, and already at that time we made a clear plea: it's not enough, this mechanical approach. We will definitely dream about merger with neurosciences, and this is a list, a wish list I like to have in all my presentations in that times, with question marks on the end, the things which we need to solve correctly, starting with lexis, syntax, morphology, semantics, etc., coming down to technical requirements, and at the end, as a most demanding task, we saw these neurosciences, neurolinguistic, neuroinformatics knowledge coming into this branch. We did see this coming, but we did not see this coming that quickly. Actually, the last point materialized the first, and it's in the domain of machine translation, and it materialized in a very quick jump. This is a picture which shows the expectations laid on machine translation. It started in post-war world. After the war, there was a huge need to try to digest the communication in other languages, basically in USA, again the Russian, and the expectations were always very high, followed by disappointment that the technology did not achieve this. And several times in history it is repeated, and the quality of the real systems were improving just very slowly. And what happened in 50 years with rule-based systems happened within 10 years with statistical systems, and happened within a year with neural systems. It went actually just 1 year between the first working prototype in 2015, before it established as a state-of-the-art system in 2016. Just 1 year. How it was possible from the scratch, that huge jump? The truth is that the technologies were already there, or the idea were already there since the beginning. The keyword to that is artificial intelligence, and the way of scientists were thinking about reusing the biology inspiration and trying to make something universal. As our brain is universal in thinking, something equivalent to bring into life for different purposes. And it really started already during the World War II with a mathematical model of neuron. And then came the perceptrons. It was already a first electrical equivalent of connected several neurons together, but actually it was never useful for anything practical. Why? Because complexity of real brains is much higher. We desperately needed more computational power, and we desperately needed more data. And this is actually what changed in 2010 to 15 in many brands. Suddenly we saw computer powers strong enough and data accumulated throughout the boom of internet and throughout the information boom bring us to very famous cases, mostly games, where machines suddenly became better than humans. It was the chess, Jeopardy quiz in the USA, all the famous examples, Google Brain, AlphaGo recently, and neural machine translation was just a logical consequence of many more complex tasks of others. And actually in 2016 there were just 3 organizations who reached already the working prototypes for themselves. It was Google, it was quite known at that time. Less known is that the World Intellectual Property Organization, and also DGT had already the working models. And our was in Hungarian, so we were actually the first with agglutinating language really working with this, and it was not easy, but it worked. I would like to also show this picture. Every year in the summer, Gartner agency publishes their prognosis, and it's about the hype cycle in the industries. Everything, when it is new, generates high expectations, and followed then by the disappointment, so the expectations go down, and it takes some time till it becomes usable and steadily uptake in the industries. And on this picture are many technologies, and what dominates on the hype top right now, it is maybe not readable that well, but on the top of the hype cycle is technology called deep learning. It is one of the things which are difficult to translate. We can use also in Slovak, maybe the English term will be okay. Deep learning, I will explain in following slides, but is also the key element behind the neural machine translation. And it depends on what for expectations you have. You may be disappointed, but also you may be quite satisfactory. At the DGT, we say for those who expect of the machine translation, of the neural machine translation, a complete understanding of the human language translating it into another, they are on their hype peak. This is not like that, but it is not going to become that quickly like that. But those who expect a practical tool, mapping in usable way inputs to outputs, they are already in the production stage. And this is DGT. So DGT actually is already with somewhere here, with using deep learning for neural machine translation. And this distinction, what for expectations we have, relates also to two distinct concepts of artificial intelligence. Many people speaking about artificial intelligence are de facto speaking about narrow AI or weak AI, and this is about all just about pattern recognition. The best pattern recognizer known to today is human brain. And we just attempt to mimic it slightly. Everything observable resides in our brain as knowledge encoded somewhere between the neurons. We will come back to this in 2 slides. And general AI is a hypothetical concept that one day maybe the machines will be thinking. When we want to stay in practical terms, we stay with narrow AI, and we will not overhype our expectations also for the translation profession, not like that. This is a picture of a semantic map which was published by Berkeley University in 2016, and it was a big surprise for many, it was assumed that we have a language center somewhere in the brain, and it was successfully mapped that actually the whole cortex is involved in language processing, and actually it was possible to locate in human activities. They were reading stories with some vocabulary of 10,000 words to seven people, volunteers, and they were scanning their brain activity in such detail that they were able to locate where the semantic concepts resides, and it was everywhere in the brain. Usually that type of activity which relates to some processing by our body, they were also involved in processing the language information related to that. This brings me to a comparison with artificial neural networks. Our machines process numbers, and these numbers could be shown and could be also analyzed by similar methods as the human brains. And the content of language put into artificial neural networks seems to be amazingly similar to what we see in brains. So for decades, it was like inspiration flowing for neurosciences into computational science, trying to establish these concepts, and now this year, actually for the first time, it happened that the computational linguists published useful work for neurosciences. Actually, this was the developers from London, those who put the AlphaGo system, who won the game Go against the world-class master. And this is coming to the scheme of artificial neural networks. And somewhere here we are deep in the processing of the language by the machine. What we see in this picture, and maybe you have seen pictures like this everywhere and many times, the small rounds are symbolic symbols for neurons, and the lines between them are symbols for connections or synapses in the brain. And to put it simply, it is only and only if we work with Exaltable. If you make a kind of decision process and make a set of criterions and put how much is this or that or another criterion important, we put some weights on it, and if we add this together, we have some recommendation from the Excel table how good is to take this decision or another. This is one simple method used in selection procedures or decision-making supporting systems, and this is also how essential our brain works. This is how very simple we can calculate it throughout the artificial neural network. But where reside the knowledge and the language inside this? Actually, as in our brains, the synaptical strength of synaptical connection is either strong or weak, and this is where all our knowledge resides. And in these artificial networks are all these coefficients. So it's a huge repository of numbers stored where we see the lines in this picture. And it is a computational science equipped with the methods how we can calculate it in between the language on the input, which is on the left side, and the language of the output, and it is on the right side. There are many more technical details how to do this, and there is not that much time left, but I can jump the more detailed theory and come to one of the next slides. We have in 2016 Translating Europe Forum conference where good materials were presented. So that was the year when we started this neural machine translation. I hope these presentations will be published. If not, just maybe I can send you. It's full of links where you can see the more details. And at the DGT, I can only say that we still follow the concept of 4 eyes principle. It was translated on a reviser in the past. With narrow artificial intelligence, we have again 4 eyes principle because we have post editor and reviser. With general, we will see, but we hope that intentionality check will be forever reserved for humans. Societies create the rules, this is the legislation, and how we can assure that the human beings will understand the law in equal way. We believe that only a bilingual human mind might answer the question whether or not the human beings will understand this in 2 languages equally. So maybe the future of the profession will be something like linguistic auditor. And some takeaway for educators. First, translators need to be really a good translator, but IT-savvy translators are really demanding. For training computation linguists, have a look at all these concepts, particularly high-performance computing, and all what people do with machine translation is becoming more and more important. It will become a platinum standard. And with this, I would like to invite you to this year Translating Europe Forum, or either in person or through the web, and you can even ask the questions remotely from that point. There are some open questions for the future. We still don't know how to incorporate editing patterns into the knowledge processing. We don't know how to unlearn machine. Some wrongs once learned it wrong. We want to work with post-editing memories in the future. We want to work with explicit knowledge. These are all unknowns for now. And above all, clean data. To that questions, open questions, maybe you have others, but for now, I thank you for your attention.
Thank you very much for that. I think quite positive start of this session. So translators will not be replaced by machines anytime soon. There will be jobs. Now we can all breathe easily, and we can take one very short question. And perhaps at the end, if we are on time, we could open it up as a panel for any remaining minutes. Does anyone have any immediate questions? Everyone's in deep thought about how to make... We have one question at the back. How do we make weak AI into strong AI in an afternoon?
Hello, just a quick question. To what extent is this driven by the willingness to economize, to save money, and to what extent is it just a technological development that needs to be followed? In other words, you said that jobs will be there, that we can rest assured that translators will be employed by institutions. You said in your presentation that IT-savvy, ICT-savvy translators will be and are required. But ultimately, is this development within EU institutions not driven by the willingness to save money rather than keep spending the same amount and employing and investing all that money in machine translation?
Thank you for this question. You are right. It is also like that, but in a reverse order. So after the enlargement the EU by 10 more languages, it was a difficult task not to exhaust the budgets after 2004 and 2007. So it was a prerequisite that tried to do more with less. So actually, the machine translation, and in particular neural machine translation, was the way out. And we see also what the industries see. The amount of translations is growing. So we cannot imagine how can we translate all the content which would be required on this planet unless we had one other planet equipped or populated only by translators. So it's not possible. And by the way, we have 2 million pages a year, mostly legislation we produce by human labor. Meanwhile, we produce 10 million pages in machine translation, and we try to assess how many of them are useful for really replace the translation which are not really needed. At least twice as much it is. So our production has doubled de facto, and this would be not possible with budgets which were available.
Many thanks for the question, and many thanks to our first speaker. Like I said, we hopefully will have some more time at the end, but there's always dinner for more conversation. So let's give another round of applause to and we'll play musical chairs in the next 10 seconds, after which Ms. Sandra Lubash will talk to us about differences in statistical and neural machine translation with a case study from Swedish into Croatian.
Okay, so first I would like to thank the organizers for having me here. I come from Croatia, the University of Zadar, and I'm a PhD student, and my field of interest includes mostly computational linguistics and machine translation. So I will be talking about something a bit similar as Mr. Flavanek before me. I'll be talking about both statistical and neural machine translation, but even more, a bit more concrete, not so theoretical and not so philosophical, but more about the concrete changes in the machine translated output from Swedish into Croatian. So I hope this will be interesting for you. First, I would like to discuss the difference between high and low resource languages when machine translating. The language with the most available resources is, of course, English, and most of the MT research is being done with English, which is something that is logical. I can totally understand why, because English is the lingua franca in the academia, so it's easier to write papers when all of your examples are in English, so it's just a very practical reason. Then there's a lot of available corpora in English. With MT, it's always useful to have parallel corpora, and instead of having to make them yourself, you can find them very easily with English, and of course the results can get quite good with English, as opposed to with low resource languages. I myself work as a translator, so Croatian is my mother tongue, and Swedish is one of my working languages, and those are both low resource languages. And I really wanted to tackle the issue of these low resource languages. I'm sure it's not very different with Slovak. These languages are often being referred to as minority languages because they lack a lot of digital content in their language. So they lack this content is necessary to build language technologies. They also lack people who would create language technologies. They lack, of course, financial support, very often also government support, because these issues are not prioritized enough. They're not being seen as something of such a great importance. The second thing I would like to discuss is my choice of machine translation system. When I was doing research with it, I chose to work with Google Translate. Now, of course, there are a lot of professional MT systems that translators use with really superior MT results opposed to those that the public can use freely. But I really wanted to use something that the people, just ordinary people, not language professionals and not translators, could use in their everyday lives. So, for example, if you don't speak German and you find a web page in German, this content may or may not be useful to you. You don't know that. So you certainly don't want to pay for a professional translator or for a translation of something that in the end may not be worth to you at all. So this is where tools like Google Translate can really be useful. It's very quick and very easy to use, and most important, it's free of charge. So you just copy and paste the content in the interface and you see what it's about. But the question that remains is, are these results any good? So can it be useful? To find the answer to that, I decided to do an error analysis on some Google translated texts from Swedish into Croatian. And this was in November 2016. And Google was at that time still using a statistical translation model. Here we have a long and complicated definition of what that is, but it's actually just that statistical translation models try to predict the statistical possibility of one word being translated with another. So it's actually very simple. And the quality always depends on the chosen source text, on information and resources that are available inside the system, in the system's dictionary and lexicon, and rules incorporated in the system, and so on. I analyzed a technical, political, administrative, and scientific corpus, so those texts, in order to make it easier for the system. It really makes no sense to work with literary or any kind of poetic text. The more controlled the language is, the better the results get. So I actually wanted to help Google Translate to give me good results, but the results were terrible. There's really no other word for that, because most of the sentences were completely incomprehensive, so the output wasn't really good. I'll get to that a bit later. So I analyzed my errors in 10 categories: in untranslated, omitted, and added words, lexical, stylistic, orthographic, and morphosyntactic errors, word order errors, consistency errors, and unclear sentences. I found all of these 10 categories very necessary. If you look at different error analysis, some researchers use less. For this category with unclear sentences, this is something you wouldn't really need if you would be working with English. But my results, these sentences contained so many intertwined errors that it was impossible to extract which error belongs to which category. So this is why I needed this, and some maybe use more. For instance, this morphosyntactic errors, this is something that you could divide into 2 categories if you think that that will be necessary. So my results have shown that Google Translate makes a substantial amount of morphosyntactic errors. So almost 50% of them were morphosyntactic, and this would be quite time-consuming for a post-editor. But actually it is the lexical errors that have the greatest impact on the level of unintelligibility of the text. So these 30% here are the most problematic when it comes to understanding or even just getting the gist of a text. It also seems that there is not so much stylistic errors, but the explanation for that is not that Google Translate is so great when it comes to functional writing styles, but it is more that there was so many lexical errors that they overshadowed the stylistic. Then we have more than 3% of untranslated words. Sometimes Google would leave Swedish words in the Croatian text, but very often I would find English words. because English is being used as an interlingua. So the first step inside the system is to translate the text into English and then into Croatian. And this may sound bad, but actually if you think about it, for an average Croatian person, it is much more likely that he or she will be speaking English than Swedish. So sometimes the English word can also help the person understand the text. Then there's almost 5% of omitted words. That makes the translation less precise, less concrete. And there's also 4% of word order errors and so on. But the numbers can't tell you everything. They can give you an insight into the problem, but you have to look beyond the numbers to help explain why is it so hard for the machine translation system to work with certain features of a language. Because with Swedish and Croatian, one of the main differences is that Croatian is a morphologically much richer language than Swedish. And this is so hard for Google Translate, and this is why it cannot produce good and idiomatic sentences in Croatian when translating from Swedish. And these differences between languages are something that human translators can understand, and they know how to deal with it, but it can get really hard for an empty system to do that. Now I will show you some of the examples from my corpus. This is a bit tricky for the interpreters because my examples are in Swedish and in Croatian. I translated them into English, and I will explain everything in English, so I hope it'll be fine. So for example, Swedish uses a kind of a formal subject, mostly in the beginning of the sentence, like here. This means 4 different models are being produced. So 4 different models, that is the subject of the sentence. But in Swedish we also have this det, that is the formal subject. And in Croatian we don't have that, so we cannot have a word-for-word translation. But this is exactly what Google Translate did. And this sentence in Croatian is just meaningless, it doesn't function. Then, like English, Swedish also has phrasal verbs, idiomatic phrases consisting of a verb and another element, typically an adverb or a preposition. And Croatian doesn't have them. So here we have the phrasal verb, how do people come to be, it's same in English and in Swedish. The denotative meaning of the verb is to come, and till is a preposition. And this should be translated with a semantical equivalent in Croatian instead of trying to reproduce the same grammatical structure. But this didn't happen. We have the same, again, a word-for-word translation. Kako smo ljudi došli do. If you speak Slovak, I think you maybe can understand some parts. And also, in these sentences, we also have other errors, but right now I'm just focusing on these errors that were systematically wrong in every case. So there's not just the error with the phrasal verbs, but right now I'll just be talking about that. Sometimes the languages share a structure, but it's not evenly distributed. So with reflexive pronouns and reflexive verbs, both Swedish and Croatian have it, but not the exact same verb is always reflexive in Swedish and in Croatian. So in Swedish and in English, the verb to enjoy is reflexive. I'm enjoying myself, but in Croatian it's not. And there has been a lot of problems with that as well. The Slovak use double negation, you know that, okay. So Swedish doesn't have that, just like English. So you would say, no step forward may be dismissed as insignificant, but in Croatian we need another negation for the verb, and this wasn't translated like that. We have the same structure again. This is the last example, so bez is a negation here, it functions as a negation, and treba is a positive verb, so this is not good in Croatian. Other frequent errors include abbreviations, compounds, and often very random orthographical errors. Google Translate would sometimes all of a sudden use all big letters or add quotation marks somewhere where they're not necessary. And this is something that generally doesn't affect the comprehension as much, but it can cost a lot of time for the post editors. So seeing all of that was very eye-opening, and I was very pessimistic about the future of machine translation because so much needed to be done and changed. However, shortly after my study had been completed, Google started using this new neural method capable of deep learning in hopes of improving the quality of these results I just got. And it is called the neural machine translation model. The biggest difference between the statistical and the neural model is that the neural model typically produces entire sentences in a single integrated model. So the sentence has a much better flow in the end, and it uses a neural network to do so. Currently, the NMT model supports translations from and into English, but recent research shows that even with other language pairs, significant improvement in the output data has been recorded. So I decided to do a re-evaluation of the same corpus I had already done and see exactly what had changed, if anything had changed. So I'm going back to the same examples I just mentioned, but now with a neural method. Here we had, with the formal subject, we had a word-for-word translation, but now the output is correct. So this is a big improvement. Google Translate used the synonym for the first verb, but it's both lexically acceptable and morphologically correct. And in my second analysis, I didn't record any problems with the formal subject. The same thing happened with reflexive verbs and double negation. So no problem with that. Same happened here. Ni jedan korak, that's a negation, and ne može biti odbačen. Ne može is again negation. So this sentence, in case of publishing, would need only very little editing. It's a correct sentence. Unfortunately, this didn't happen with all of the categories. This phrasal verb example, how did people come to be? And now the translation is kako smo došli. And this is a morphologically correct sentence, but Google Translate just omitted the preposition, so we got the wrong meaning instead. Previous studies on neural machine translation show that this is something that the systems do now. They omit or leave a considerable amount of words untranslated. So the translations are less precise. My results stand in correlation with the expectations and findings from the previous studies. Generally, the translations are much more morphologically correct. There is less lexical, less orthographical errors, but there are much more omitted and much more untranslated errors. So a post-editor would have to be very careful with omitted words, because like in this sentence, it can sound good, but it's the wrong meaning. So you have to be a bit more careful here. So in conclusion, I would say that when it comes to low resource languages and publicly available MT systems, the NMT model is really a huge step in the right direction. Morphology and syntax are much better now, but there is still a lot of room for improvement. In general, there was still a lot of errors in my output. The terminology was not rendered in a very good way, and there was still a lot of completely unclear sentences. So this has to be fixed. Of course, with high resource languages, the output is much better, so especially with English, and even when it comes to translating from or into Croatian, and there has been research in the meantime that show that. A solution to this would be to create much more digital content in Croatian and other low-resource languages. It would be to work on language technologies that tackle our language-specific problems, like rich morphology. I think that every country needs to realize that in this modern and global age, your language has to be visible digitally in order to stay relevant. And in this day and age, it's really a human right to have access to information on the internet, no matter the original language. So this is why I like to work with publicly available resources, and why I welcome this improvement from Google Translate and hope to witness further development regarding this topic. Thank you for your attention.
Sandra, for also mentioning a couple of key concepts for our students in the room of control language, of pivot languages and translation as well. Is there a quick question that we could take now? Or would you... Oh, we have one from the floor.
Thank you for a nice presentation. I expected that some additional explanations will come up after the very theoretical background at the beginning. One thing I wonder how it is possible when looking at the mistakes categorization, I saw a relatively low percentage of word order mistakes. And between the language like Swedish and Croatian, one is with fixed word order, and the other one is more based, like Slovakian, I hope, on theme, rim, tema, rema, that introducing the subject and then going on. This is a known problem which the big players don't want to solve, like Google, they don't need it because people anyway understand. And for professional translators, this would be actually a big solution because we see it constantly, the people need to swap part of the sentences. You have the low number because of you categorize only when it impacts the understanding, or was it really so good? Any comments?
Thank you for your question. Well, one of the problems with the categorization is that sometimes it's unclear where should you put which mistake or which error. So sometimes you can put it also as a syntax error. So maybe that is one explanation, but also the other thing is that in Croatian we have a very, very free word order. We can really we can just have different kinds of alternatives that all function very well. So I didn't categorize these errors as word order errors unless it was completely incomprehensible. Any other questions?
I'm afraid we will need to save them for the end of the session, but I would like to thank our presenter again. And this round of musical chairs will involve our third presenter for today, Mr. Alireza Yazini. I should apologize to all our presenters for totally making a hash of their names, pronouncing them incorrectly. I'm very sorry. So in the next presentation we will hear about term extraction efficiency for one particular tool, Logiterm, and we'll hear about a comparison between monolingual and bilingual texts.
Okay, just need to copy-paste my file, sorry. So, yes, I'm a joint PhD student at the University of Ottawa and KU Leuven University in Belgium. I'm really happy to be here presenting among you, and I'm really looking forward to receiving your feedback and comments, because what I'm going to present is not in my main area of interest. It's my second research interest, because I'm working on language and translation policies in the media for my PhD thesis. So, let's see. Okay, it's in Slovak language, so it's okay. Here, let's see. I hope it's reading my USB. Okay. It seems it's reading.
This is all planned, it's part of building up expectations.
Okay, sorry. So, I'm gonna start with a short introduction of this tool. It's a translation tool called Logiterm Web, which was developed in Canada by a company called Terminotics, which also develop other tools like different term extractors and other kind of software for translation or terminology management. So yeah, it's a web-based, user-friendly interface that provides access to terminology, to bytext and full text, so you have your own data. You can save your database there. And then it's also complemented with other tools like search engine, and there are other utilities such as document alignment, so you can make bytext, and there's term extraction, pre-translation, and some other utilities. As you see, this is the main interface, and there are some tabs here. You can make your bytext, you can do some pre-translation with your translation memory, you can have your terminology and some other functions. For those who are not familiar with term extraction, I just have a quick review. Terms are considered lexical units used to designate concepts in a thematically restricted scenario. And term extraction or identification and selection of terminological units in specialized text are fundamental tasks for the building of dictionaries, taxonomies, and ontologies, as well as the translation and organization of text data according to Da Silva, Conrado, and others. So term extraction is really important, especially for translators, because some of you use translation tools, and you want to quickly make a term record, most of the time bilingual, and save them and use them as, for example, a dictionary, or in your TM, as a part of your TM, to do faster translation and increase your productivity. So I can say it's related to translation. That's why I decided to present this study here. There are some basic term extraction approaches that I've listed here. The first one is statistical approach. It's like simple language and domain-independent methods, such as n-gram statistics or word frequency. So in this approach, how you select the candidate terms depend on for example, the frequency count, how many times a term is repeated in a specific text. And then there is linguistic approaches, which use lexical, syntactic, semantic, and discourse analysis and other types of linguistic methods. But most of the time, because there are drawbacks for each method, a combination of these two are used. There are also some more advanced methods that I'm not going to get into, because Logiterm uses just a combination of statistical and linguistic approaches. As you see here in a tutorial by Terminotics, the developer of the software, and this screenshot, which is from the settings of the linguistic functions for term extraction, you can select unilingual text or bytext, so you can do extraction from either of these. And then it's important to choose your source language, which language you want to do term extraction in, because it changes the syntactic algorithm of the software. So it's really important to choose what language you want to use. And this is another screenshot from the term extraction function in Logiterm. As I said, it uses both statistical and linguistic methods. You see the frequency count on the left for these candidate terms. And as you see, most of them are phrases, such as noun phrase or adjectival phrase, because it's a linguistic approach. So, and a drawback is that one-word terms are usually silent, because using linguistic approaches, you cannot identify one-word terms. And as you see in this tutorial, it says that Terminotics experts say the extracted terms that Logiterm deemed relevant, unlike many other types of software, Logiterm outputs is a very clean list with no adverbs, verbs, etc., which is a claim that, it's one of the claims that has inspired this study, that I'm going to see if it's really the case or not. So the motivation behind this study is these three elements. One of the most powerful functions in LogicTerm is term extraction, as claimed by Terminotics. It can search for potential terms both in unilingual and bilingual text. It's usually run before translating many documents to extract repetitions at the term level, create terminology records, and apply them throughout the translated documents to ensure consistency. Another claim they make is, according to their tutorial, the integrated term extractor in LogicTerm focuses on unilingual term extraction, meaning whether monolingual text or bi-text are used, the candidate terms will only show up in one language, in this case either French or English, because they have just developed this to be used for French or English, not other languages yet. And it is emphasized that in this term extractor, creating terms from bi-text is more efficient since you can choose the equivalence from a bilingual context. And the third one is, as the LogicTerm developer claims in the same tutorial, they say unlike many other programs, LogicTerm output is a very clean list with no adverbs, etc. So they claim that there is no noise, or the candidate term list is just like correct terms that, and which is a claim that says this tool is perfect. So the aims of my study are to find out whether LogicTerm's term extraction results for unilingual and bilingual text in English and French differ in terms of precision, which is the correctness of the candidate terms, and recall the degree of coverage of the candidate terms. And to find out if there is consistency in term extraction behavior when using text in different formats, because you can also do term extraction in web pages like HTML files, not only in PDF or Word format. The third is to find out how clean the results of the LogicTerm term extraction are, and to measure the satisfaction of users with LogicTerm's term extraction results for English and French Word documents. I'm not going to generalize anything. It's an exploratory study and it's really preliminary. But I really hope to get feedback either after my presentation or like in a coffee break to develop this paper. There have been some studies on term extraction. Some of the researchers just described their new methods, approaches to term extraction, and some dealt with how to assess the results, the output. And one of the reasons I started this study was that there was no specific study that dealt with a specific tool and to compare like term extraction on monolingual and bilingual text and different text formats. So my methodology, as I said, it's exploratory, and I'm not going to generalize anything. I use term extraction function in LogicTerm web client, this specific version, because they update every time. And I use two texts from LogicTerm sample disease bitext. It comes with a couple of sample bitext and monolingual text. So I used the bitext and I extracted the monolingual text. And also I used two websites of the Government of Canada and saved the web pages, made the bitext, and also used the monolingual text, because the Government of Canada has both web pages in English and French. And I also did a small scale survey. I asked 5 PhD students at the University of Ottawa in translation studies who were both fluent in French and English through convenient sampling, because I needed students who were fluent in both, and it was kind of snowball sampling. I used a short questionnaire with close-ended and open-ended questions to see how they evaluate the output of this term extractor and why they think this is the way it is. So here you see some, just some parts from my data. I had 2 texts from 2 monolingual texts, both in English and French, and also 2 from web pages of the Government of Canada. I have just put here some parts of them. As you see in this Word file about gum disease in English, monolingual English on the left, for the term gum disease, the term extractor showed 29 frequency counts, while in the bytext, so English-French bytext, it showed 31 cases of gum disease. So it's one of the discrepancies in that output. And then number 12, you see there is a typographical change from hormonal change with a capital H to hormonal change with lowercase h. And I saw patterns in these changes, which can be interesting. In the next slide, you see the monolingual French version on gum disease, and also the bytext on the right. Again, there was no discrepancies in word count, in term frequency count, but as you see number 10, again, there is a typographical change or difference. So, changement hormonal with a capital C to changement hormonal with a lowercase c. In the rest of this French, in the French output, you see there is some noise in the bytext of the word file. You see on the right, dental professional and disease FRA, which is an unknown noise. And then gum disease, which have appeared in the French results, which is strange because the tutorial claims that their tool only yields terms in just one language, like monolingual results. But you see English terms in the French data. And then there is another text, but this time HTML format. Again, in English, you see on the left there is some noise. And you see some of them are nonsense because the reason might be because of the structural difference or the underlying structure of the HTML format, the web page. So it's one of the flaws or shortcomings of this term extraction on HTML files. And again, I saw some patterns. For example, as you see in the bytext, there's less noise, which needs more research and investigation. Okay, it's the rest of the French HTML file. And again, wait. Okay, this is the English one, and then here, okay, I haven't included the French. So these were some patterns that I noticed. I have summarized the analysis of my data. It needs more work. I hope I can get more feedback. So as you see, the amount of recall and precision in term extraction from both monolingual and bilingual English word files were almost the same with minor noise in the bytext data due to the interference of the title of the files. So I investigated more, and I saw that the title in the bytext, I don't know why, maybe because of some technical issues, is counted as a term record in the bytext, which needs maybe more investigation. The same happened for term extraction in the French word text with interference of the titles in the bytext. For unknown reasons, some English terms, for example, dental professional, as I said, appeared in the French bytext. So English terms appeared in the French results. In the cases where one of the two terms started with a capital letter, as I said, the typographical difference, it seems that term extraction in monolingual text, which is a pattern, opted for the one starting with a lowercase letter, and in bytext, it opted for the one starting with a capital letter, hence resulting in typographical differences. Compared to the monolingual word files, more noise was observed in the candidate terms extracted from the monolingual HTML files, both in English and French. Surprisingly, term extraction for the bytext of HTML files showed cleaner results, which is also interesting because it's a bytext and we expect maybe more noise because there are two files involved and then it complicates the structure and the term extraction. The noise observed in English monolingual HTML files seemed to be more of a technical type, whereas in the French results, the noise seemed to be of a linguistic type, as there were English terms among the French candidate terms. So, in my conclusion and implications, the results of this preliminary study show that using bytext in a term extraction in large term function is not always more efficient and can contain more noise compared to monolingual text, especially in word format, although they claim that term extraction is more efficient in bytext. Large term extractor behaves differently in terms of recall and precision when different file formats are used. So if you use a Word document and HTML document, it can behave differently. There is more recall but less precision in HTML files, for example, in this study. This might be due to the underlying structures of the files used. Claiming that the term extraction results are clean is far from realistic, and more improvements need to be made to achieve such a goal. And the findings of this study can inform users about the choice of text and their expectations when using large term extraction, and can help large term software developers improve this function in later versions. Thank you very much.
Many thanks. And I'm pretty sure lots of translators in the room are now breathing easily that they don't have to compile bytexts. They can stick with monolingual files. Any immediate question that we could take? Not at the moment. Thank you very much for the demo. If we have time at the end, we can have a small panel. Otherwise, we can keep talking about this at dinner. Thank you. So in our last performance of musical chairs, Jana Štekovičková, almost.
It's fine, okay.
Hashtag massive fail on my part, apologies. We'll be talking about the impact of translation methods on translators' productivity, and we'll hear about human translation, post-editing, as well as using of CAD tools. So without further ado, many thanks, and over to you.
Okay, so hello everybody, thank you for the introduction. So my name is Jana Štekovičová, as was already said. And this experiment was made together with Mr. Absalon, and we decided to entitle the experiment The Impact of Translation Methods on Translation's Productivity, a comparative analysis of human translation, post-editing translation, and computer-aided translation. Very long, I will put it simple. So to start, I would probably tell you a little about myself, but it will be two topics, don't worry. So when I was in high school and I was deciding where to go to university, and I decided translation studies, I thought of translation as something like this. You take a text, a source text, you open up Word and you translate line by line. Maybe you look up some word in online dictionary, or in this case Google Translate. And this was for me translation. When I was a bit more lazier, and I didn't want to translate line by line, I took a section or the whole text, put it into Google Translator, and I was waiting what is going to come up, and I took the results of the translator and just corrected the mistakes. And now the one that I didn't know it existed, and I met this method at the university, is using CAD tools. So with CAD tools, you have translation memory, which was created by person, or there is also this option that gives you machine translation, and you can choose or you can translate yourself. Now we have then three types of translating: human translation, post-editing of machine translation, and cat tools and translation memory. Now I was thinking, why do we have three types of translation? Why don't we have just one, the fastest one, the most effective one? Why do we have to choose? Now I realized that it is because we don't know which one is the most effective one and which one is the fastest. So we decided to make an experiment about this. Now the experiment was made in 2017 in winter, and we asked my colleagues from studies. It was my 4th year at university, and the students also studied English, so the English was language for everyone. And we took 15 students and put them into a group of 5 people. So we have 3 groups of 5 people, where each group translated in different order. So the first group translated the first with translation memory, then human translation, and then post-editing of machine translation. Then the second group translated in different order. It was post-editing of machine translation, translation memory, and human translation. And the third group, human translation, post-editing of machine translation, cat, and translation memory. You can't remember that right now, I understand that. I will repeat that while I speak. So what we chose a text. Now we were thinking what to decide to translate. We wanted it to be something that students know about. They already know some background. And as it was in 2017, we decided to use a topic about Brexit. It was very popular that day. So the text was about Brexit. There was some EU terminology, but not very often. And we parted this text into 3 sections, where each section was translated in different way. Now, the cat tool that we used for translation memory was memsource. And why memsource? It's because the students knew how to work in memsource. They studied the software before, so we knew it's not going to be a technical problem or technical issue for them. Each translation with each method was 30 minutes. So they had 30 minutes to translate, then they stopped. And at the end of the experiment, we asked them to give us some feedback. So it was which was for them the best, which was the worst, and why. Now, what did we get? The results that we see right now are divided by groups. So the first group, as we see, translated in order TM, HTP, PEMT. And then translated. The bottom line means the total number of segments, and the orange line is average. So in the first group, with translation memory, out of 47 segments, they translated 29. Out of 49 with machine translation, 18, and out of 57 human translation, 24. As we see the results everywhere, translation memory was the fastest. So with translation memory, they were able to translate the most segments. Now, what was interesting, the least or the slowest one was translation with post-editing of machine translation. We see that here, first group, only 18 segments, second group, only 9, and third group, 19. Okay, third group did 1 more segment than HT, but it's not very high difference, it's just slightly. So that was the slowest one. It was, for me, it was very surprising, because I was thinking, okay, post-editing machine translation, there is some help. It's not perfect help, but there is some help. TM, there is a help. Translation memory is a very good tool. And HT, you have to go from scratch. You have nothing to work with. You have to work by yourself. And even though it was faster than machine translation. And then another thing that we can see, that the order of the methods mattered, because every time students translated the first method slower, than any other group in different order. So what does it mean? It means that the first group was translating with translation memory, the first, and translated only 29 segments. The second group worked with translation memory on second place and translated 41 segments. And the third group translated with the translation memory as the last one, and they managed to translate the whole text. So it was also quite surprising, but we can explain that the first translation, they were getting to know the text, and maybe some words were surprising, but later on in the text, they already know how to translate them, so it took them no time. Then we compared the results by time. This means the average time spent on segment using translation memory. Number of words, average number of words in segment was 22, and students managed to translate them almost in a minute, which is quite nice. This was the fastest version. Then it was the human translation, which was the second fastest, where in a segment in average was 17 words, and they translated it in 96.3 seconds. Well, and the slowest one, post-editing of machine translation, in average 23 words in a segment and more than 2 minutes, which is quite a big difference when we see that 22.8 and not even a minute, and 22.9 and more than 2 minutes, which was quite surprising. Now, we were thinking, why was it like this? Now, there was the feedback that helped us, and I will just read out 3 of the feedbacks. The first one, for me, the best way of translating was the one with no help. I was able to translate freely and did not have to take anything into account. The worst one was translation with TEM, even though the translation was quite good. But I was quite lazy, and it was hard to think apart from the translated version, and it took a lot of time and effort to check it with the source text. The text was interesting. I was using Linguistic while translating, where I could easily find some specific terms typical for EU language. So maybe this is a point of view of a student starting translator, that he wants to have fun while translating. Maybe when he will be professional one day, he will enjoy working with TM. But even though the HD, human translation, was the best one for him because he felt freely, he didn't have to check anything and so on. The second feedback, the worst translation, was post-editing of machine translation, because the translation was not correct in many cases and needed a lot of corrections. This translation also copied the syntax of source text. The best way of translation was, for me, human translation. I did not have to correct any mistakes and could be fully focused on my translation. So again, more or less the same feedback. And the third one, the best translation method for me was kept with TM. It is the most effective one, but I think this is only with longer texts. Well, the professionals say the opposite, but again, a feedback from a student. Okay, so to conclude it, the most effective method of translating is TM, at least according to our experiment. It was again Slovak and English and Slovak language combination. Least effective method of translating is post-editing of machine translation, but again, it was made in 2017, and it was combination of English and Slovak. So, as Sandra said, if the same experiment would be made English and French, the results would be probably very different. And the first translation, using any method, was always slower than the same method later in the order. And students and their skills in MemSource, they were at that time, they were students of the 4th year at the university, and not one hand was up to ask me how to click on anything or how to save anything. So very good job for the students as well. Okay, thank you for your attention.
Thank you very much. First of all, for bringing up a topic dear to everyone, Brexit, and then secondly, for showing us that some linguists like making mistakes but not necessarily correcting other people's mistakes. Are there any questions?
I have two questions for you. Thank you very much. It's really interesting to compare. It's really interesting to compare these three methods of translation. But as one of your participants said, that it's hard for them to compare the source text and the target when using TM. I'm wondering what type of cat tool was used. This is my first question. And because I use cat tools on TM, I wanted to say that the completeness of the TM that you are using here in this cat tool can really affect the result of the study. How did you control that?
Okay, so the cat tool was memsource, and we text,
only memsource?
Only memsource. The text was previously translated with mistakes made on purpose. So I knew where the mistakes were, and there was not a match that was 100%. It was only mostly 75% of match. So there were segments that had to be translated always. So it wasn't just clicking, yes, this is correct, this is correct. But they had to work on it, and they had to check it, even though it was with translation memory.
Okay.
Hello? Yes, thank you. So our presenters have been wonderful, and we are fully back on track with time to spare. So if anyone has any questions for all of them, now's the time. We have a question at the back.
Thank you. Do you think the language pair can affect the success of MTP? I mean, from English into Slovak, it's obviously, well, it's a difficult language combination because of the differences between languages. But if it was, I don't know, German into English, do you think the results could be better?
It's a question on me, I guess.
Yes.
I think they could be better because, as Sandra was saying, there are high and low resource languages, and also for the Google Translate and for these machine translators, they have better matches when they translate. So I did not do this experience, but I believe it would be different according to this.
Can we find out about the experience of the DGT with different language pairs and various levels of success?
Actually, a lot of these things change with starting to use neural machine translation. So the neural machine translation help mostly for most difficult languages. So we group it traditionally in three groups: analytical languages, inflected languages, and most complicated agglutinating languages. And nowadays it helps for all our languages, or in all departments. They started to use it since we have the neural quite actively. I don't say, and I don't pretend that everybody does use it, but it's definitely majority of the staff that use it, and at least half of our production is made by this. And this is across all languages. But still, the morphologically richer languages, the more difficult it is for the machine, be it statistical or also be it neural. So these differences between languages. And for efficiency, maybe just one simple comment. First, translator has to be a good translator. Then some additional skills are necessary to become a good post-editor. So I am not surprised with this experiment, and maybe even for more comfortable pairs, maybe the results might be the same, I would expect, because if you are not used to correct the machine, you are so afraid of to keep it. So you think a lot, and you have to think hardly before you get really carried. So these skills have to be developed. At the beginning, I remember the tips from companies like SDL after 2 years using it, you can get really efficient with post-editing. We had some kind of rule, don't give up at least for 2 weeks and then judge first. And right from the scratch, translating first sentence in the machine translation, it is never efficient in our experience.
And I guess for professional translators, there will also be the differences between light post-editing and full post-editing. I'm guessing at the EU you don't actually do light post-editing, so slightly more challenge.
It is a nice question. Actually, it was in the part I had to skip due to the lack of time. At the DGT we had also in offer light post-editing, and it was outsourced. Basically, we put this type of quick and rough post-editing work on the freelance market, and we saw quickly it was quickly diminishing its use. So in the past, when machine translation was not so good, it was for several thousands of pages from our requesters to get, instead of full professional translation, to get quick and dirty post-editing, light post-editing, and the tendency was towards zero. So actually we made rigorous testing in 2016, and it was proven there was no interest anymore in light post-editing. So we concluded that either for gist purpose it was good enough, what we have already with neural machine translation, or a full human translation is necessary. For in our practice, light post-editing disappeared.
On that bombshell, I think we should thank again our presenters. Again, sorry for keeping you 2 minutes over, but we are fully back on track, and I fully enjoyed their presentations. I'm sure you did as well, and I'm looking forward to talking to them more during the coffee break. So thank you all.
Thank you.